Welcome back to Pratik Academy. In this video, we will see some basics related to refrigeration. So, what is refrigeration? Then, refrigeration. What is this refrigeration? In our house or in cinema theaters or in hospitals, we found ACs. Then, in our house, there are refrigerators, or in ice cream parlors, we see big refrigerators. What is the work they do? Their work or duty is to lower the temperature of surrounding or that body which is placed inside refrigerator or the cabin in which they are placed to lower temperature of that body or cabin is the purpose of that refrigerator or ACs. Okay, so the branch which deals with lowering the temperature and maintaining that temperature is a refrigeration, or we can also call as a it is a process. It is a process which deals with lowering temperature lowering temperature of body or cabin and maintaining that temperature. Okay. Lowering is also important, and maintaining lower temperature is also important in case of refrigeration. Then we require one device to lower this temperature. Then the device which is used for this purpose is called as a refrigerator. Okay. Refrigerator is device used to maintain or reduce temperature of cabin. Okay. Now we have to lower temperature in case of refrigeration. So for that purpose we have to, or we require to remove heat from cabin to surroundings so that temperature will be lowered. Okay, then there are another, so that means refrigerators remove heat from body, remove heat from body and add heat to surrounding or environment. This is the working, or this is the function of refrigerator: remove heat from body and add heat to surrounding. Then in case of winters or in European countries, there is environment is at always at lower temperature. For their the people in European sides, they require to add heat to room so that they feel comfort. Okay, then in that case their purpose is to remove heat or absorb heat from surrounding and add heat to room. Okay, here refrigerator, here upper part, it removes heat from body and adds to surrounding so that people will feel comfort at lower temperature in summer conditions or in India side. Okay, where there are high temperature conditions, but in case of European sites there are conditions of low temperatures, or environment is always at lower temperature. In that case the people feel comfort when we add heat to room and increase temperature of room. So for that purpose we require to absorb heat from surrounding and add to room. Then the device used for that purpose is called heat pump. Refrigerator removes heat from body, adds to surrounding. Heat pump opposite to it, remove heat from surrounding and add to room. Okay, if we draw diagram here, both are working between two thermal reservoirs, higher temperature and lower temperature. Okay, so in case of heat refrigerator, we require to initially, okay, suppose this is a refrigerator, so we use refrigerator only when summer conditions or high temperature conditions. If temperature is lower, then what is the use of using refrigerator? So we are using refrigerator in summer conditions mostly. Then environment is at higher temperature. Then if initially there is no refrigerator, then our body or room is also at high temperature. Then our purpose is to remove heat from that body. Suppose this is the environment and this is the room or body. Both are at higher temperature initially. Then we use refrigerator is reducing heat from the body and adds to environment. Okay, this is the refrigerator. Okay, as we reduce heat from body, then temperature of body starts to decrease and it will attain some lower temperature, TL. Then our diagram changes to here, TL. Heat is removed, QL, and it is at higher temperature, QH is heat added by refrigerator. Here we are reducing heat, temperature is continuously decreasing. Okay, this is the body. But here we are continuously adding heat, but environment is at high temperature. Why? Because environment is large in size, so adding small amount of heat will not affect on its temperature, so its temperature remains constant. Then now this device is removing heat from lower temperature sides to high temperature sides. Okay, this is called a refrigerator. Okay, and it requires some external work, mechanical work. Without any mechanical work, it cannot remove heat from lower temperature and add to higher temperature, and required work is QH minus QL. Okay, so here this is the purpose, this is the body, and this is the environment. Okay, if you take heat pump, okay, when we use heat pump in winter conditions, okay, in winter conditions both environment and body, this is the body, see, body and environment both are at lower temperatures. Okay, then here we using device called as a heat pump that will remove heat from environment and add to body. Okay, now again if we add heat to body, its temperature starts to increase. Okay, so and then after some time it will attain some higher value here, TH, by adding heat here. Then there are two temperatures, TH, TL. This is the heat pump. Okay, QL is the heat removed from, this is the environment, remember this is the body, and QH is the heat added. Now here we are adding heat to body, its temperature will increase because its space or volume is very low as compared to environment. Adding or removing heat will changes its temperature. But in case of environment, similar to this condition, here with reducing small amount of heat from environment, it will not reduce its temperature. So here TL remains constant, but here TL is attaining higher value. And again here we have we have to transfer heat from lower temperature environment to high temperature body. Again we require work. This is the required work is QH minus QL. This is the heat pump. Again here, what is the desired purpose? Desired purpose is to add heat. So this is the purpose. Okay, this is the basics of refrigerator and heat pump. Both are working on same law. This is Clausius statement. Okay. Clausius statement. Okay, we know that according to Clausius statement, to remove or to transfer heat from lower temperature to higher temperature, we require some external work. Okay, without any external work, this device is not possible. Without any external work, this device is not possible. Okay, but both are working on same Clausius statement. Both are transferring heat from lower temperature to higher temperature, but main difference is here. Here, to remove heat from body is the desired purpose, QL temperature, and here add heat to body is desired purposes. It is the difference between these two devices. Then so these two devices, refrigerator and heat pump. Then how to check performance of these two devices? We have one parameter, COP, coefficient of performance. This is defined as it is ratio of desired effect or required effect upon work supplied. Okay. Work supplied. Then if we apply this definition for refrigerator, COPR, it will comes to desired effect is to remove heat, it is QL, upon work done is W. Then it will changes to QL upon work done is here QH minus QL. So this is the COP of refrigerator. Then for COP of heat pump, again same definition, desired effect upon work done, and here it changes to QH upon W, and again QH upon W is equal to QH minus QL. And there is one interesting relation between COP of heat pump and COP of refrigerator, is that COP of heat pump is always greater than 1 by that of COP of refrigerator. So this is the relation. This is simple relation. You can obtain this by simply putting value of QH in this equation. Okay, so this is the refrigerator and heat pump. Again in refrigeration, next point is the unit of refrigeration. Unit of refrigeration. If we observe in our definition, in this device, working of this device, our purpose is to remove heat. Okay, and this heat should be removed at some particular or some specific rate. So in case of refrigeration, it involves with removing or heat transfer at particular rate, at some specific rate, or in simple language we can say refrigeration is deals with heat transfer rate. In case of refrigerator, it is heat removing rate. In case of heat pump, it is heat adding rate. So we know that. So unit of refrigeration, then SI unit of refrigeration is simply unit of heat divided by time. That is, heat divided by time is heat rate. So unit of heat is joule and divided by time second. So watt is the SI unit of refrigeration, but it is very small, so usually it is expressed in kilowatt. Okay, kilowatt by simply dividing it by 1000. This is the SI unit. Okay, but there is another unit, commercial unit, that is tons of refrigeration. Tons of refrigeration. Okay, will okay. Tons of refrigeration. Okay, or simply TR. First, listen definition. It is the rate of heat transfer required to convert 1 US ton of water at 0 degree Celsius at 0 degree Celsius to convert it into ice at 0 degree Celsius within 24 hours. So tons of refrigeration, again, this is the one particular heat rate. The heat rate required is such that we have to convert 1 US ton of water, which is at 0 degree Celsius, into ice again at 0 degree Celsius and within 24 hours. So there is a time limitation and temperature limitations and mass limitations. So pictorially, initially we have water. Mass of this water is 1 US ton. US ton of water. Its temperature is 0 degree Celsius and this is taken in one box or container. Now we have to convert this water into ice. Okay, convert it into ice. Again, mass remains same. We have to maintain its temperature same, and this conversion, there is a time limitation within 24 hours. This conversion should be take place. Now we know that to convert water from ice, we have to remove heat from water, and again, as temperature remains same and we are changing only phase from water to ice, we have to require some latent heat from water so that water is converted into ice. And initially water is at 0 degree Celsius, so we have to find out what is the latent heat of water at 0 degree Celsius, and this value is approximately equals to 337 kilojoule per kg. That means if you want to convert 1 kg of ice, which is 1 kg of water which is at 0 degree Celsius into ice, we have to require to remove this amount of heat. Now this is for 1 kg. Our mass is 1 US ton. Then 1 US ton is coming, okay, 1 US ton, as per definition, it is not just ton, it is in US ton, and it is equal to our 900 kg mass, not 1000 kg mass, 900 kg. This definition is from US, so they have taken 1 US ton and it is equals to 900 kg. So total mass is here 900 kg. So total heat required to remove is equal to 337 into 900. Okay, that much amount of heat is required to remove. So our target is not to remove this heat, but required to remove this heat in 24 hours. So heat rate required heat rate or heat removal rate required is equal to 337 into 900 divided by 24 hours. Okay, because we want this conversion in 24 hours, and if we solve these values, okay, here unit is kilojoule, here initially it is kilojoule per kg into kg, so convert it or it becomes kilojoule, and then kilojoule per 24 into 3600, so second. So this is equal to or coming to be equal to 3.516 kilojoule per second, and is equal to 3.516 kilojoule per second is kilowatt. So this amount of heat is called as a 1 tr. Okay, 1 tr or 1 ton of refrigeration, it is defined as it is the rate of heat transfer or heat transfer required to convert 1 US ton of water, which is initially at 0 degree Celsius. Important is temperature is 0 degree Celsius, and we have to convert it into ice, which is again at 0 degree Celsius. So only phase change occurs, or we are interested in phase change, no any sensible cooling or heating, and this conversion should be in 24 hours. So this value is approximate, this value can be changes, some figures will be can be there differences in this figure. I have taken here 337. So at 0 degree Celsius, latent heat of water is 337 kilojoule but per kg. Here given mass is 1 US ton, and this is equals to coming to 900 kg. Okay, 1 US ton is equal to 900 kg. Remember this conversion. Then total amount of heat required to remove is 337 into 900 kilojoule, but we are interested in rate, heat rate. So heat rate is coming to be 3.516 kilowatt, and this is equal to 1 tr. So when they said your refrigerator is of 2 tr capacity, that means it is having 2 into 3.516 kilowatt heat transfer rate capacity, or half ton capacity, that means half of this value. Ton does not means weight of that refrigerator or AC, it it means heat transfer rate. So this is related to basics of refrigeration. In this video we have seen definition, then difference between heat pump and refrigerator. Important is that both are working on Clausius statement, both are related to heat transfer from low temperature to high temperature, but purposes are different in both. Then last important is unit. This is commercial unit. TR is a commercial unit and SI unit is kilowatt. So relation between commercial and SI is 1 TR is equal to 3.516 kilowatt. So this is for basics of refrigeration. Thank you for watching. If you like this video, please subscribe our channel.